Hi, one of the basics for working in Algebra 2 is to understand the use of and the definitions of real numbers. So just some of the background basics for you for your first section here. Real numbers are defined as sort of all the numbers that we're going to use until we reach square roots, when we will actually reach some things that are non-real. But up to this point, you've probably only dealt with real numbers. Real numbers include whole numbers, numbers such as 6 or 12, the positive counting numbers, integers, which also include negative, positive, and positive counting numbers. So 6, -6, -12, things like that. Rational numbers, which are numbers that can be written as fractions. So that's when you put two integers in a ratio, thus the name rational numbers. So things like 2/3 or 0.7 repeating, which again can be rewritten as 7/9. So if it can be written as a fraction, it can be a rational number. Also in the real numbers, but not in sort of that progression, are the irrational numbers. Whole numbers are always integers. All integers are rational numbers, but numbers that are not rational are known as irrational, such as pi or the square root of 2, numbers that could not be written as just a ratio of two integers. A good symbol for all real numbers is an R with sort of a double bar on the left side. So if you ever see us use that symbol, you'll know we're referring to the set of all real numbers. Also remembering how to graph, such as a simple graph like a number line. Remember that the origin is where your number line starts. Your actual graph, or the coordinate grid that you're using, the green line, would be your graph. And the coordinates are just any number that corresponds to a point, such as the red point over the number 6 right here. Now, to work with the real numbers, we also have some properties for a couple of operations, such as addition and multiplication. The associative property, remember, is to just literally reassociate or regroup. So if you're looking at the associative property, if you have 2 plus 3 in parentheses here, then plus 5, you can regroup that as 2 plus parentheses, 3 plus 5 and parentheses, forcing you to add the 3 and the 5 first, but still end up with an answer of 10. That same associative property works for multiplication. So we can force the 3 and the 5 to multiply first, but then multiply the 2 afterwards. That's when you reassociate or regroup using parentheses. The commutative property is, we're using that word commute, or to actually move. So the commutative property is taking 2 plus 3 plus 5 and making it into something like 2 plus 3 plus 5, only in a different order. So we're doing 3 plus 2 plus 5. Or in multiplication, you can reorder any of those three letters to multiply in a different order. There's also a property called closure, which is very rarely used property. Just realize that any two real numbers that you ever add together, the answer will be a real number. Any two real numbers multiplied, your answer will be a real number. If you want more of a definition of why we need closure, ask your teacher. The most popular of the properties is probably the distributive property. That's where you're taking two things added together, then multiplying by a number. Or if we want to do it in a different order, you can distribute. We can take a times b, then add that onto a times c. Remember that you're using sort of multiplication and addition together in that property. The identity property is if you take anything, such as a plus 0, you just end up with a. Or a times 1, if we're doing it with multiplication, the identity of multiplication, a times 1 would just be a. That's often confused with the inverse property. Inverse property says if you take a and add that, again we're doing the property of addition, onto its opposite. So a plus negative a would be 0. Or something like 1/2 times 2. If you multiply those two things and they give you 1, they give you back the identity, then you've used the inverse property. One way you'll be using that in your homework is to actually justify why we can do operations on equations and expressions. So if you look at the expression or the equation that we're given down here below, we want to prove that the left side equals the right side. So the first thing you might do, and you might do this without even really thinking, is you may reorder. Inside the parentheses, notice we changed the 6 plus 4x into a 4x plus 6. Justifying that statement, well, we switched the order. We moved them around. That's the commutative property of addition. Then, in order to actually add, in our minds we may be saying, well, let's add 3x to 4x. But remember, we have to do parentheses first. So if we regroup those by moving the parentheses, we've used the associative property of addition. And then finally, to actually add those, we're just using the definition of addition. So that's how we'll use the properties within our homework. The last thing that we'll do in this section, very quickly, is what's called unit analysis, or working with labels. If we want to change 88 feet per second into a different label, we just need to use conversion rates. Knowing that we have feet here, we could easily convert that into miles, knowing that a mile contains 5,280 feet. So if I take 88 feet per second and multiply that by 1 mile per 5,280 feet, notice that feet on the top and feet on the bottom, those two labels cancel away. And if they're gone, the only label we'll be left with for distance is miles. The same thing goes for seconds. Seconds on the bottom here will cancel with our 3,600 seconds per hour. And notice the only two labels that we're left with are miles per hour. Now our job, knowing that we've canceled all our labels correctly, is just to actually do the multiplication and division. 88 times 3,600, multiply the top of those two fractions. They're both being divided by 1, so that part really doesn't matter. It'll just disappear. Then we're dividing by, notice we multiply by 1 but divide by 5,280. And if we go ahead and do that, 88 times 3,600 divided by 5,280 actually comes out to 60 miles per hour. So let's do the same thing with 52 miles per hour on the bottom here. We've got 52, we already have miles, and we're talking in 1 hour. But we want to be in inches per second. So let's deal with the miles first. Knowing that there are 5,280 feet in a mile, we can at least make one jump to get our labels into feet. Now we want inches, so we're going to have to make a second step. Because feet are on the top, I'm going to go ahead and put 1 foot on the bottom, knowing that there are 12 inches in 1 foot. That means that miles will cancel away, feet will cancel away, and we're left with inches. Now let's do the same thing to convert our hours into seconds. I know that in 1 hour, and notice because hours was already on the bottom, I'm going to put it on the top, there are 60 minutes. And again, in 1 minute, I know there are 60 seconds. Again, hours on the bottom, cancel the hours on the top. Minutes, go with minutes. And the only label we're left with on the bottom is seconds. Now all we have to do is crunch the numbers. Take everything on top, 52, 5,280, 12, technically 1 and 1, and multiply all those numbers. On the bottom we have 1 times 1 times 1, and 60 times 60. And if we multiply out the top, divide it by 3,600 on the bottom, we will end up with 915.2 inches per second. I hope that helps you with unit analysis, and good luck on your homework.